This time we've got a platform that's supported on a tower. I think it's off an oil rig or something like that. It's got a mass of 200 kilograms, and they've kindly shown us where the centre of gravity is, and they've dimensioned it. And so we would just probably show something like that. Just show a little centre of gravity symbol. Remember what those are like, so it's like that, and then you colour in those two bits. Now in this case, that's all good, There's not too much more to say. So I've drawn a little free body diagram. To be honest, I haven't done it to scale. We're interested in the platform itself. So we've got a support here by a cable. So we need to replace that by a force. And that cable is stopping this platform falling in this direction. Okay, so it must have a force going in the opposite direction. And so should really start with, that's a reaction force, should start with the primary forces first. There's nobody in this apparently. And so primary force would just be gravity, or the weight, sorry, it's not really gravity, it's not a force, it's an acceleration. The weight is a force. There's a mass of 200 kilograms, so we want to figure out what that force is. So weight is equal to mass times gravity, which is equal to 200 kilograms times 9.81 meters per second squared, which is equal to 19.62, hold on, times, this would be 1962, 1962 newtons, because we put in kilograms, so it's coming out in newtons, and I'd probably just change that to kilonewtons, 1.962 kilonewtons. That's okay. So now we can put that value on here, 1.962 kilonewtons. Did I do that before? I did. Just check and actually put the forces on. Okay, then we've got all our primary forces because the gravity is the only one. Now we just have to be careful here. So what we're doing is we're taking a three-dimensional object and we're simplifying it to a two-dimensional problem. We can do that because it's all symmetrical, but we just have to be careful about, this is the total weight. Okay, this is the total weight of that platform. This looks like it's just one cable, but really there's two cables there. So if we do all the calcs, and let me just show, just draw on that cable now, or the force, we won't draw the cable, I'm drawing a free body diagram here, but what we will do is draw the force associated with that cable. So that cable's stopping it falling down the way, so the force is going in the other direction. We'll call that F1, say, or R1. Yeah, let's call it R1. R1 is in that direction. And then what we've got down here is a little pinned connection there. So if you either figure that out or look it up, it can't stop rotation, but it can stop translation in any direction. And so you need two components, and those two components can add together to give you translation in any direction. So you're going to have a component like so, and another component like so. This is going to be R2Y, say, and this is going to be R2X, something like that. And we're going to figure out what those are. I've just drawn them in the positive direction. I think they would actually be that way because it's going to want to rotate this way, so we're going to need some kind of moment. Anyway, that doesn't matter. Now, why was I telling you to be careful? You've used the total weight here. And so if you do all these calculations, this reaction is going to be the total reaction in both of these connections, because you've used the total weight. So at the end, you'd have to divide all of those by 2 to find the reactions at one of those or in one of those cables. With the ruler altogether. An alternative would have been to just calculate the reactions here and half the weight, because only half of the weight is going to go to each side. But just be aware of that if you're taking a three-dimensional problem and turning it into a two-dimensional problem. Nothing wrong with that, but you just have to be pretty careful about thinking about how many components are causing this force, and then divide by the end. If it's more than one of them are responsible for that force, divide at the end. Hope that makes sense. Quick one, next one.